Hello everybody, welcome to Unit 1, Section 4. We're going to be talking about the interior of the Earth. So first things first here, we're going to do a little thought experiment, or if you'd like, you can actually perform the experiment yourself. It's very simple to set up. Imagine that we get a glass jar and we fill it with all sorts of different materials. We have rock, we have things that are soil, and not just one kind of rock. Maybe we have this kind of rock, and we have these white rocks that are from this other place, and we have branches and little organic material in there, and water and air and all of it, and we shake it up and let it settle. Take a moment, think about what would happen. So the very densest stuff is going to sink to the bottom over time. Above that, you're going to have the stuff in the middle, your medium density rocks that aren't quite the heaviest stuff in there. And then you're going to have your soil, dirt, the lighter organics at the top, and then you're going to have water and then air. And this is actually very similar to what has happened with the Earth. So the interior of the Earth, it's not the same stuff throughout, right? It's not the same 1,000 miles down as it is 10 miles down. Instead, it's separated on a large scale into these big layers. And just like with the glass jar, the reason that the stuff at the center is because it's so dense that gravity has pulled it down past everything else, all the way down into the center of the Earth. So our term for this is differentiation. Uh, this is the process that has given Earth its layers. And it's not just Earth, it's true for all of our terrestrial planets. Uh, we talk about first Earth's crust, the thing on the very outside. This is the thin skin of Earth, the thin rind, the scum which has come up to the surface. And I'm sure you already know this. The things that we call mountains, this is the light stuff compared to what is underneath it. Thin, low density, rocky, and solid. Next we have the mantle. So this is mostly solid, but partially molten material. For the most part, it is hot silicate rock. This is actually the biggest of Earth's layers, sort of intermediate in density, but still something which might resemble rock material, as opposed to what we have in the core. These are our innermost layers. So we have all the high density stuff here. Our outer core is liquid metal, and our inner core is going to be this solid mass of iron nickel alloy at the very center. And you may think, well, why is it solid at the center and not liquid if it's going to be so hot there? And this is actually because the pressure at the center of the Earth is so great that it holds all of the material down there into a solid form. There is so much pressure coming in from all sides from the weight of all the Earth above it that it squeezes it into a solid form. The other planets in the system have differentiation too, but for now we're just going to talk about Earth. And this is just a little diagram showing it here. You see we have the very, very thin crust on top. We have our huge mantle of material underneath, the outer core, and then the inner core. And something interesting here, just a question to throw out there. We've said that the outer core is liquid, but have to ask the question, well, how do they know that? How can they be so sure? Why are people willing to risk their lives on the fact that the outer core is liquid? And I'm not going to answer this, just something to think about. The access code for the assignment is 1234. So next, section 5, we're going to talk about Earth systems.